Hi, the course title is Mastering Python Programming. This course is all about understanding of Python and use of Python in various domains like cloud platform, machine learning, and data science. In this course, you will be learning about basics of Python programming, features in Python, exploring on cloud client libraries in GCP, the use of Python in data science, working with ML application using Python, practice environment used in the course to do the activities. Let's have a look on what is Python. Python is easy to learn and it is powerful programming language. Python has syntax that allows developers to write programs with fewer lines compared to other programming languages. Let's have a look on the course description. In this course, you will learn the basics such as data types, data structures, statements, functions of Python, installing and configuring Python IDLE. You will learn the implementation of an application using OOPS concept, creating the database and executing the queries, understanding how to install and configure Python client libraries in GCP, and creating application in GCP. You will also learn how Python is used in data science and machine learning. Let's have a look on the target audience for this course. They are developers interested in Python, Python developers, data scientists and data analysts, software developers and cloud developers. Let's see the prerequisites to begin with this course. Understanding of basic Python programming, free tier GCP account, working knowledge on GCP cloud services, basic knowledge on ML algorithms. Now let's have a look on the lessons for this course. The lesson 1 is all about the basics of Python programming. In the lesson 2, it is advanced features in Python. In lesson 3, you will learn using Python in cloud programming. In lesson 4, using Python in data science. Fifth lesson is all about Python for machine learning. Let's see the practices for the lesson 1. Installing and configuring Python IDLE, working with data structures, implementing conditional and looping statement, implementing user-defined function by using modules and packages. In the lesson 2, you will be implementing an application using OOPS concept and Python application to read and write the file. Then you will create a database and execute the queries, and creating threads and executing multi-threading applications. In lesson 3, you will install and configure Python client libraries in GCP, then creating an application to get user details using Python libraries. Using Python client libraries, you will create an instance in GCP. Let's have a look on the practices for lesson 4. You will install and configure Anaconda and Jupyter Notebook. Then you will do the processing CSV, XLS and JSON data. Then create visualization by using chart properties and chart styling, and implementing Python application using chi-square. In the fifth lesson, you will implement clustering by categorizing items to group, and implement ML application using linear application, then classify the handwritten digits using Python, and you will create a decision tree. Let's see the practice environment required to do this course. You will require GCP account to access the cloud resources and GCP Cloud Shell. To summarize, in this lesson, you have learned about detailed course objectives, course description based on the objectives, course target audience, prerequisites for taking up this course, detailed course schedule, practice environment used in this course to do the activities. You are in lesson 1, Basics of Python Programming. In this lesson, you will be learning what is Python and its features, difference between versions of Python 2 and Python 3, data types and data structures in Python, conditional and looping statements in Python, what are functions, modules, and packages. Let's have a look on what is Python. Python is a dynamic, high-level, free, open source and interpreted programming language. It supports object-oriented programming as well as procedural-oriented programming. The code runs through an interpreter which converts the lines of codes into the language understood by the computer. These are the features of Python. Python uses an elegant syntax and easy-to-use language which runs anywhere in any platform. Python's interactive mode makes it easy to test short snippets of a code. Python is easily extended by adding new modules implemented in a compiled language such as C or C++. It can also be embedded into an application to provide a programmable interface. Let's have a look on the differences between Python 2 and Python 3. Python 2 has two strings, namely Unicode and non-Unicode strings, whereas in Python 3 all the strings are Unicode by default. In Python 2, print is a statement and in Python 3, print is a built-in function. In Python 2, there is separate int long types for non-floating point number, whereas in Python 3, there is only one integer type. Xrange function in Python 2 is used to create iterable objects, and in Python 3, it is replaced by range function. In Python 2, exception must be closed within parentheses, whereas in Python 3, exception must be enclosed within notations. Let's see the data types in Python. These are categorized into three types. They are single value data types, collections, and Boolean. The data types are int, float, long, char, which comes under single value data types, strings comes under collections, and true, false comes under Boolean. Let us understand the pre-built data structures provided by the Python. They are string, list, tuple, set, and dictionary. Let's see the data types individually. So let's look into the strings. String is a sequence of characters and it is immutable. For declaring string, use the double quotes or the single quotes. The syntax for string is variable equal to characters within a single quote or double quote. Now let's understand what is list. List is a collection of data items enclosed within square brackets and it is mutable. The syntax for list is variable is equal to collection or single valued elements separated by comma. You can see the example for list. Now let's look into tuple. Tuple is a collection of data items enclosed within parentheses and it is immutable. The syntax for tuple is variable is equal to collection or single valued elements separated by comma. You can see the example for tuple. Let's see what is set. A set is a collection of well-defined and distinct objects enclosed within a flower braces. In set, repetition of elements is not allowed. The syntax for set is variable is equal to collections or single valued elements separated by comma. You can see the example for set. Let us have a look on what is dictionary. Dictionaries are the key value pair which is enclosed within flower braces. In dictionary, the key and value are separated by colon, and the key should always be enclosed within double or single quotes. The syntax for dictionary is variable is equal to open flower brace key with a value. You can see the example for dictionary. What are conditional statements in Python? The conditional statements are similar to decision-making statements which executes set of statements when it is true and false. The types of conditional statements are if else, if else, and nested if. You can see the sample Python program which defines the conditional statements in Python. What is looping statement? A looping statement allows to execute a set of statements again and again until the condition is satisfied. The two loops in Python are while loop and for loop. Let's understand how while loop works. While loop is usually used when the number of iterations is not known. The while loop will run the set of statements again and again until the condition is satisfied. The syntax explains if the condition of the while is true, then it executes the statements. Let's see what is for loop and how does it work. For loop is used when number of iterations are known. If the number of iterations is not specified, then the loop runs infinite time. The syntax for loop is for with variables in collection and statements. The next topic is functions. Let's see what are functions. Functions are the block of statements or collection of instruction which is identified by a name. Functions get executed only when the function is called. So what is function call? It is the process of sending the control from the main space to the function body for the execution of the instruction that is present inside the function body. You can see the syntax for defining a function. Here, the arguments and return is not mandatory. You can also see the syntax for calling the function. Let's see what are the types of functions. There are three types of functions. They are built-in functions. These are the predefined functions in Python. User-defined functions. These are the functions which are created and defined by the user. Anonymous function. These are the one-line function. Let's see the types of parameters passed to the function. There are three types of parameters that are passed to the function. They are default parameter, keyword parameter, and special parameter. So how do you pass the default values to the arguments? The passing default value is a phenomena where we assign the default values to the formal argument so that if the argument is passed or not, the function gets executed. You can see the syntax for passing default values to the arguments. Here, argument 1, argument 2 are mandatory arguments and n argument 1 and argument 2 are called as non-mandatory arguments. What is scope of variable? The scope of variable is a phenomena where the variable can be accessed in the program. There are two basic scope variables. They are local variable. It is accessible only within the function definition. Global variable. It is accessible throughout the program. Let's see how to pass collection to a function. A function can take any arguments like variable, collections, and functions itself. In this type, the collection is fed as input for the function. You can see the example for passing collection to a function. What is recursion? Recursion is a process where it calls itself again and again. It is a phenomena where the function is passed in the function call. You can see the example that is factorial of a number, which defines the recursion. Let's see what is lambda function. These are the function without specific name and gets stored into a memory and returns the address wherever it is stored. All the small functions will be performed using lambda functions. The syntax for lambda function is variable is equal to lambda with arguments, colon, return value or expression. The example for lambda function for adding of two numbers is function is equal to lambda a comma b colon a plus b. Let's have a look on what is map function. Map function is used to perform similar actions on the sequence of the values. You can see the syntax for map function. Now let's see what is filter function. Filter functions are used to filter the values that are present in the collection by using the method returning Boolean value. You can refer the slide for the syntax of filter function. What is zip function? It is a function which is used to zip the values present in two collections and stores it as a dictionary. The function returns the address of the memory where the dictionary is stored. The syntax for zip function is zip with collection containing keys and collection containing values. Let's have a look on dir function. It is a built-in function which returns attributes and methods of an object. The syntax for dir object is dir with object, and the example for dir function is dir with dictionary. Let's see what are arguments and keyword arguments. If the number of arguments to be passed in the function is not known, then use arguments. The default type of arguments is tuple. Now let's see keyword arguments. In this function, only dictionary is passed. This function is used when the number of keyword arguments is not known. Now let's understand what are modules. A module is a file containing Python definitions and statements. Basically, they are Python files with .py extensions. Usually import and from keywords are used to get the functionality of the module. Import. It is a keyword which is used to get the specified module. The syntax for modules is import module name. Suppose a particular function has to be fetched from a module, then use the syntax module name dot function name arguments. To import specific modules or function present in a module or package, then use the syntax from module name import function1 function2 and so on. Let us see what packages is. A package is like a folder or directory which holds the module and the sub-packages. Here sub-packages are other package which resides inside the main package. Let's see the steps to create a package. The first step is create a directory, then populate the directory with .py files, create init.py and leave it blank or place the initialization statements. Then create a main Python file consisting of import statements. In this lesson, you have learned about what is Python and its key features, difference between versions of Python 2 and Python 3, data types and data structures in Python, conditional and looping statements in Python, what are functions, modules, and packages. The practices for this lesson are initializing and configuring Python IDLE, exploring on data structures in Python, implementing conditional and looping statement, and implementing user-defined functions by modules and packages. Practice for 1-1. Installing and configuring Python IDLE. In this practice, you will learn to install Python IDE and configure pip. Before starting this practice, you can download the document for this practice from the resources. The document illustrates the step-by-step approach to this practice 1-1. You can copy the link from the document to download the Python IDE. Select Download Windows 84 Executable Installer. Wait for a few minutes to download the latest version of Python. After the installer is successfully downloaded on your local machine, double-click on the executable file, that is Python 3.9 AMD. As the installer runs, click Install Now. Now click on Close. On successful installation, verify that the setup was successful. The next step is setting up the path for Python IDE and configuring pip. Verify the installation location and path of the Python IDLE in your local machine. By default, Python is installed in the path users, user, app data, local, programs, Python, and Python 39. Now run system properties advanced.exe in the run dialog box. Click Windows plus R, type as system properties advanced.exe and click OK. You will be prompted with the system properties. In this pop-up, click Environment Variables. Select Path under System Variables and click Edit. Here, click on New to add the path. Copy and paste the path of Python IDLE. Now click on OK. Further set the path for pip. Click on Edit and click New. Now copy and paste the Python scripts path. Navigate to the folder and select Scripts folder. Copy the path of the Python scripts and paste here. Click OK to close the environment variable dialog box. The next step is to create Python IDLE desktop shortcut on your local machine. Now navigate to Python IDLE installed path on your local machine. You can follow the path which is provided in the document. Navigate to App Data, click on Roaming. Here click Microsoft, select the Windows folder, then select Start menu, click on Programs. Here click on Python 3.9, right click on IDLE. From the drop down of Send to, select Desktop. Verify that the Python IDLE shortcut is created on your desktop. You can see Python IDLE shortcut is created. This concludes your practice 1-1. Practice for 1-2. Exploring the basic data structures in Python. In this practice, you will learn about the usage of Python basic data structures such as strings, lists, tuple, dictionary, and sets in programming. Before starting this practice, you can download the document for this practice from the resources. The document illustrates the step-by-step approach to this practice. Double-click on Python IDLE shortcut on your local machine. Now let's explore the basic Python data structures. You can refer the document for the syntax of string. A is equal to elephant. The string should be encoded in double quotes or the single quotes. To retrieve the string value, provide the variable name. You will get the output. Now let's look into the list. L is equal to, it is the combination of data types. You need not provide the integer value in the single quotes or double quotes. On successful execution, verify the output by providing the variable. You can see the list displayed in the Python shell. Now let's execute the example for tuples in Python. On successful execution, verify the output displayed. Now let's execute the example for dictionary. The syntax for dictionary is key value. The key and the value is separated with a colon. It is combination of all data types. On successful execution, verify the output by providing the variable name. Now let's create set. S is equal to list of numbers or a string separated by commas. This defines a set. On successful execution, verify the output. This concludes your practice 1-2. Practice for 1-3. Implementing conditional and looping statements. In this practice, you will create and run a GCD Python program using conditional and looping statements. Before starting this practice, you can download the document for this practice from the resources. The document illustrates the step-by-step approach to this practice. Double-click on Python IDLE shortcut on your local desktop. Click on File and select New File. Save the file by clicking File and Save As. Select any folder and save the file name as gcd loop.py. Click on Save. Now copy and paste the code which is provided in the document. Now save the file by pressing Ctrl S. Click Run from the menu and click on Run module. Now enter the first number as 7 and the second number as 14. You will get the output GCD value. Now close the file and close the Python shell. This concludes your practice 1-3. Practice for 1-4. Implementing user-defined function by using modules and packages. In this practice, you will create user-defined functions and call these functions using modules and packages. Before starting this practice, you can download the document for this practice from the resources. The document illustrates the step-by-step approach to this practice. Double-click on Python IDLE shortcut on your local desktop. Now let's create a new file. So click on File and click New File. Save the file with the name myfunctions1.py. You can copy the code from the document for myfunctions1.py. This code consists of the functions to swap two numbers and to find a Fibonacci number for nth digit. Save the file myfunctions1.py. Now let's create a new file. Click on File and click New File. Save the file with the name myfunctions2.py and click Save. You can copy the code from the document. This code consists of the functions to check whether the string is palindrome or not, and to check the given number is prime number or not. Save the file by pressing Ctrl and S. Now let's create another file in Python shell. Click on File, click New File. Save the file as modulefunction.py. Copy the code from the document and save the file by pressing Ctrl and S. In this Python code, the main module is defined and it calls module myfunction1.py and myfunctions2.py. Save the file and click Run from the menu. Further click Run module. On successful execution, verify the output. Enter your choice. 1 is Armstrong, 2 is generate Fibonacci numbers, 3 is check whether a number is prime or not. You can see the output. Now you can select any one from the below choice. Further, you can choose 3 to check whether the number is prime or not. Let's give the invalid choice. You will get the message as invalid choice. You can now close the file and close the Python shell. This concludes your practice 1-4. Following this, you will have the quiz on this lesson. You can skip the quiz, however, I would suggest to take the test for your self-analysis. You are in Lesson 2, Advanced Features in Python. In this lesson, you will be learning about Python OOPS concepts, decorator and generator, Python constructor, exception handling and file handling, regular expressions and wildcards, connecting to the database, multi-threading and multiprocessing. Let's have a look on what is Python OOPS concepts. The object-oriented programming concepts in Python include class. It is a group of objects or it's a blueprint of objects defining the common attributes and behavior. A class is defined under a class keyword. Objects. It is an instance of a class. It has an entity that has state and behavior. Method. Method is a function that belongs to an object. These are used to define the behaviors of an object. Inheritance. It means inheriting or transferring of characteristics from parent to child class without any modification. The new class is called the child class or derived class, and the class from which it is derived is known as parent class or the base class. The types of inheritance are single inheritance, multi-level inheritance, hierarchical inheritance, and multiple inheritance. Polymorphism. Polymorphism is a property of an object which allows it to take multiple forms. The two types of polymorphism are compile time polymorphism and runtime polymorphism. Data abstraction. The abstraction is used to hide the internal details and show the functionalities. An abstract class cannot be instantiated, which means it cannot create objects for this type of class. It can only be used for inheriting the functionalities. Encapsulation. Encapsulation means building up of data in a single class. It is used to restrict access to methods and variables. In encapsulation, code and data are wrapped together within a single unit from being modified by accident. Let's see what are decorators in Python programming. The decorators are the powerful tool that allows a user to add new functionality to an existing object without modifying its structure. Decorators allow users to wrap another function in order to extend the behavior of wrapped function without permanently modifying it. You can see the syntax of decorator. Let's see what are generators in Python programming. Python provides a generator to create user's own iterator function. Generator is a special type of function which returns an iterator object with a sequence of values instead of a single value. User can easily create a generator expression without using user-defined function. It is same as the lambda function which creates an anonymous function. You can see the syntax for generator. Advantages of generator are easy to implement, memory efficient, pipelining with generators, represent infinite stream. Let's see the constructors in Python programming. The constructor is a special type of function which is used to initialize the instance members of the class. The constructor is used to create an object in Python. Creating the constructor in Python uses the method init, which simulates the constructor of the class. Every class must have a constructor, even if it is simply relies on the default constructor. Constructor can be of two types. They are parameterized constructor and non-parameterized constructor. Let us see the exception handling in Python. An exception is defined as an unusual condition in a program which results in the interruption in the flow of the program. Python provides a way to handle the exception so that the code can be executed without the interruption. It uses try and except keywords to handle the exceptions. You can see the syntax for exception handling in Python. Let's look into the file handling using Python. Python allows users to handle files, that is, to read a file, and with many other file handling options to operate on files. Each line of a file is terminated with a special character called the EOL or end of line characters like comma or new line character. The order of the file operation is open a file, read or write, then close the file. Now let's understand what is file operation. Python provides an open function which accepts two arguments. They are file name and access mode in which the file is accessed. Syntax to open a file. File object is equal to open, file name, access mode and buffering. The different modes for opening a file are read, append, write and create. After writing into a file or reading a file, the next method of handling a file is close a file. Python allows users to close a file using close method. Any unwritten information gets destroyed once the close method is called on a file object. These are some of the file methods in Python, such as file close, file flush, next file, file read with size, file read line, file read lines, file seek offset from, file tell, file write, file truncate. Let's see what are regular expressions. Regular expressions are used to match or find other strings or set of strings used a specified syntax in the pattern. The Python module RE provides the support for Perl-like regular expressions in Python. Syntax for regular expressions is re.match with pattern string flags is equal to 0. In the syntax, pattern is the regular expression to be matched, string is the one which is to be searched to match the pattern at the beginning of the string, and users can specify different flags using the bitwise OR. These are the wildcard characters or the special characters used in regular expressions. Let's see the steps to connect to the database using Python programming. In step 1, we'll import the database module and then create the connection object. After creating the connection object, create the cursor object, then execute the query. The first step is importing the database server module. In the first step, we'll import the database server module. For example, import SQLite as SQL. After importing the database server module, the second step is to create the connection object. In this step, we'll create the connection between Python application and SQL database. Once we create the connection, the next step is to create the cursor object. The last step of connecting to database using Python programming is execute the query. Let us understand what is multi-threading in Python. Multi-threading in Python programming is a well-known technique in which multiple threads in a process share their data space with the main thread, which makes information sharing and communication within threads easy and efficient. Multi-threading is very useful for saving time and improving performance, but it cannot be applied everywhere. Multi-threading in Python can be achieved by importing the threading module. There are two modules to handle threads in Python: thread module and threading module. We'll look into the syntax of thread module. The syntax to create thread module is thread.start new thread with functions and arguments. And you can see the example of thread module. Let's see what is threading module. The threading module exposes all the methods of the thread module and provides some additional methods. They are threading active count. It returns the number of thread objects that are active. Threading current thread returns the number of thread objects in the caller's thread control. Threading enumerate returns a list of all thread objects that are currently active. Threading module has thread class that implements threading. The methods available by the thread class are run, start, join with the time, is alive, get name and set name. Creating threads in Python. This slide tells about how to create threads in Python. The three ways to create threads in Python are without creating a class, without extending thread class, by extending thread class. Let's see what is multiprocessing in Python. Multiprocessing is the ability of the system to run one or more processes in parallel. Python provides the multiprocessing module to perform multiple tasks within the single system. Multiprocessing is essential to perform the multiple tasks within the computer system. Let us understand what is Python multiprocessing classes. Python multiprocessing module provides many classes that are most commonly used for building the parallel programming. The main classes are process, queue, and lock. These are the functions of multiprocessing such as pipe, start, run, is alive, terminate, kill, queue size, get, current process, parent process. In this lesson, you have learned about Python OOPS concepts, decorator and generator, Python constructor, exception handling and file handling, regular expressions and wildcards, connecting to the database, multi-threading and multiprocessing. The practices for this lesson are implementing an application using OOPS concept, Python application to read and write the file, creating a database and executing the queries, creating threads and executing multi-threading applications. Practice for 2-1. Creating a Python application using OOPS concept. In this practice, you will learn to create a banking application using object-oriented concept in Python. Before starting this practice, you can download the document for this practice from the resources. The document illustrates the step-by-step approach to this practice 2-1. Double-click on Python IDLE shortcut on your local desktop. Create a new file by clicking on File from the menu and click New File. Save the file by providing the name bankapplication.py. Click on Save. You can copy the code from the document. This code consists of the functions to deposit, withdraw amount from the account and to check the available balance in the account. Save the file by pressing Ctrl S and run the code. Click on Run from the menu. Click Run Module. You will have to provide the choice. Click on 1 to deposit amount. Enter the number of amount. Now select the option as available balance. You can see the available balance. Now you can choose any of the options like withdraw. Now check the balance. Likewise, on successful execution, you can verify the output by providing the choices. You can close the file and close Python shell. This concludes your practice 2-1. Practice for 2-2. Python application to read and write the file. In this practice, you will learn to create the file, write the data to the file, and read the data from the file using Python. Before starting this practice, you can download the document for this practice from the resources. The document illustrates the step-by-step approach to this practice 2-2. Double-click on Python IDLE shortcut on your local desktop. Create a new file, click on File and select New File. Save the file by providing the name as filehandling.py. Click on Save. Now you can copy the code from the document. Save the file by pressing Ctrl S. Now let's run the code by clicking on Run from the menu. Click on Run module. You can see the message reading data from the file f1.txt. Now let's open the directory where the file is saved. You can check for f1.txt file existence. Open f1 text file and you can view the data in the file. Close the notepad, close the file and close PowerShell. This concludes your practice 2-2. Practice for 2-3. Creating threads and executing multi-threading applications. In this practice, you will learn to create threads and perform multi-threading with a process. Before starting this practice, you can download the document for this practice from the resources. The document illustrates the step-by-step approach to this practice 2-3. Double-click on Python IDLE shortcut on your local desktop. Create a new file. Save the file by providing the name. Let the file name be multithreading.py and click Save. Copy the code from the document and save the file by pressing Ctrl S. The code consists of the function to find the square and cube of the number. Let's run this code by clicking on Run from the menu, further by clicking on Run module. You can verify the output. Now close the file and close Python shell. This concludes your practice 2-3. Practice for 2-4. Connecting to database and executing the queries. In this practice, you will learn to connect to database, create student table, insert the rows into the table, delete the row and query the table based on condition in SQLite database. Before starting this practice, you can download the document for this practice from the resources. The document illustrates the step-by-step approach to this practice 2-4. Double-click on Python IDLE shortcut on your local system. Create a new file, click on File and click New File. Save the file by entering the name as connectdb.py. Click on Save. Copy the code which is present in the document. Save the file. Now let's run the code by clicking on Run from the menu. Click on Run module. Enter the name for the database. After entering the database, it creates a table with the name student. Let's enter the number of data to be inserted. 5. Name of the student. Enter the phone number of the student. enter the name of the second student, phone number, likewise enter 5 student name. You can see the details of the student. Now enter the name to delete. The details of the student with the name John is deleted. Now you can close the file and close the Python shell. This concludes your practice 2-4. Following this, you will have the quiz on this lesson. You can skip the quiz, however, I would suggest to take the test for self-analysis. You are in Lesson 3, Using Python in Cloud Programming. In this lesson, you will be learning about GCP and its architecture, cloud client libraries in GCP, exploring Python client libraries, execution of Python application which uses Python libraries, creating instance in GCP using Python libraries. Let's see the introduction to GCP. GCP provides business with ease access to the cloud systems and other computing services developed by Google. The GCP consists of a set of physical assets such as computers and hard disk drives and virtual resources such as virtual machines through which it provides service to business. The services of GCP are computing and hosting, storage, databases, networking, big data, and machine learning. This is the architecture of Google Cloud Platform. Let's see what are GCP projects. Any Google Cloud resources that user allocate should belong to a project. A project is made up of the settings, permissions, and other metadata that describe applications. The project can access another project's resources only when the user is using shared VPC or VPC network peering. Each Google Cloud has the project name, which is user-defined, project ID, it can be user-defined or Google Cloud can provide for user, project number, Google Cloud provides it. Each project ID is unique across Google Cloud. Once you have created a project, you can delete the project but its ID can never be used again. Let's see what is Google Cloud Shell. Google Cloud Shell is an interactive shell environment for GCP. Google Cloud Shell provides the following to the user: built-in code editor, 5 GB of persistent disk storage, pre-installed Cloud SDK and other tools, language support for Java, Go, Python, Node.js, PHP, Ruby and .NET, web preview functionality, built-in authorization for access to Cloud Console projects and resources. Users can perform Google Cloud tasks by using gcloud command line tool. It makes it easy for users to manage the projects and resources without having to install the Google Cloud SDK and other tools on user's system. gcloud tool lets user to manage development workflow and Google Cloud resources in the terminal window. Let's understand what is Cloud Client Libraries in GCP. Google Cloud Client Libraries provides API for the two main purposes. App APIs provides access to services. APIs are optimized for supported languages such as Node.js and Python. The libraries also provide helpers for authentication and authorization. Admin APIs offer functionality for resource management. The Cloud SDK includes client libraries that enable user to easily create and manage the resources. The Google Cloud API client libraries provide access to the API REST interface only. gRPC is not supported. Enabling APIs in GCP. To use a cloud API, user must enable it for the project, depending on which services and which projects are involved in an application. Steps to enable an API for a project using the console. The first step is navigate to Cloud Console API Library. From the projects list, select the project you want to use. In the API library, select the API you want to enable. Then, on API page, click Enable. Exploring Python client libraries. The Google API Client Library for Python is designed for the Python client application developers. The library provides high-level API abstractions, hence they are easier to understand. Let's look into the features of Google API Client Library for Python. Call Google APIs simply, handle auth with fewer lines of codes, use standard tooling for installation. What is authentication and authorization in GCP Python Client API? The API methods are used to determine the appropriate access. First method is Simple API Access. The simple API calls do not access any private user data. To authenticate your application, use an API key for your Google Cloud Console project. Every simple access which calls your application must include this key. The second method is Authorized API Access. The authorized API calls access private user data. Before you can call them, the user that has access to the private data must grant your application access. Therefore, your application must be authenticated. The user must grant access for your application and the user must be authenticated in order to grant the access. Let's have a look on the steps to execute an application using the Python libraries. First step is to log into a GCP account, then create a project in GCP. After creating a project, initialize the GCP Cloud Shell, then create a bucket in GCP. The last step is to execute Python code using Python libraries. The first step is log into GCP account. Provide the credentials of GCP account and log in. Once you are logged in, the next step is to create a project in GCP. In GCP console, create a project by clicking New Project and provide the details, then click Create. After creating the project, the next step is to initialize the GCP Cloud Shell. Click Terminal icon to open the Cloud Shell. Run the command gcloud init to initialize the Cloud Shell and click Authorize to the configuration settings. Then the next step is to create a bucket in GCP. Click Browser under Storage in GCP console, then click Create Bucket, provide the details and region and add advanced settings and click Create. The last step is to execute a Python code using Python libraries. Create a file and copy the code inside the file. Execute the code and view the output. Let's see the steps to create an instance in GCP using Python libraries. In the first step, we will configure the project settings, then create VM using Python libraries and verify the VM is created successfully. The first step is to configure the project settings. Configure the GCP project settings. After configuring the project settings, create a VM using Python libraries as highlighted in the slide. You can see the instance is created. Let's see the last step, that is, verify the VM is created successfully. Navigate to App Engine and click VM Instance and verify the VM instance is created successfully. In this lesson, you have learned about GCP and its architecture, Cloud Client Libraries in GCP, Python Client Libraries, execution of Python application which uses Python libraries, creating instance in GCP using Python libraries. The practices for this lesson are installing and configuring Python client libraries in GCP, create an application to get user details using Python libraries, using Python client libraries, create an instance in GCP. Practice for 3-1. Configure Python client libraries in GCP. In this practice, you will learn to configure Python client libraries in GCP. Before starting this practice, you can download the document for this practice from the resources. This document illustrates the step-by-step approach to this practice 3-1. Log into Google Cloud Platform account by providing the credentials. Now the next step is create a project in GCP account. Navigate to GCP console, click on select a project and click new project. Provide the project name as my project SDK and click on create. The project is creating. Now let's verify the project is created or not. In GCP dashboard console, click on select a project. You can see the project name that is created. By clicking on the project name, you will get the project information such as project name, project ID and project number. In the GCP console, click on the terminal icon to activate the Cloud Shell. The next step is setting up the configuration of gcloud with the project. Let's run the command gcloud init to initialize the Cloud Shell. Now the gcloud is requesting your credentials to make a GCP API call. So click on authorize. Choose the configuration to use. Here press 1 in the Cloud Shell to reinitialize the configuration. Now choose the account in which user wants to perform operations. Now select the project to use. Choose the options accordingly. On successful execution, you will be connected to the project that is created with the name My Project SDK. You can now close the Cloud Shell and keep GCP console open for the next practice. This concludes your practice 3-1. Practice for 3-2. Create an application to fetch user details using Python libraries. In this practice, you will learn to create a bucket and create an application to fetch user details using Python libraries. Before starting this practice, you can download the document for this practice from the resources. The document illustrates the step-by-step approach to this practice 3-2. The first step is we'll create a storage bucket in GCP to create an application which fetches user details using Python libraries. Click on Navigation menu in GCP console. Then navigate to Storage. Click on Storage. Then click on Create Bucket. Provide the name for your bucket. Now click on Continue. You should provide the unique name for the bucket. Now choose region under location type and select the location as US Central 1. Then click on Continue. Choose the default storage class for the data as standard and click Continue. Further select the access control for the objects as fine grained, then click Continue. In the advanced settings, select Google Managed Key and leave the other options as default and click on Create. You can see the bucket is created. Now open the Cloud Shell and create a file. Click on terminal icon. Now create a file using VI editor, VI authenticate 3.py. Once the file is created, click on Open Editor. You can copy the code from the document and paste in this file. Save the file by pressing Ctrl S. Close the file and click on Open Terminal. Let's run the command to execute the code. Python 3 authenticate 3.py my project SDK and the project ID. On successful execution, view the description of the project, My Project SDK. Keep the Cloud Shell open for the next practice. This concludes your practice 3-2. Practice for 3-3. Using Python client libraries to create an instance in GCP. In this practice, you will learn to create and delete the instance using Python client libraries. Before starting this practice, you can download the document for this practice from the resources. The document illustrates the step-by-step approach to this practice 3-3. Let's create a VM instance in GCP using Python libraries. First step is to create a file as startupscript.sh using VI editor. VI startupscript.sh. Close the file. Now click on Open Editor. Select the file startupscript.sh. You can copy the code from the document and paste it here. Save the file by pressing Ctrl and S. Now open the terminal. Now let's create a file as vi create.py. Once the file is created, now click on Open Editor. Now select the file create.py, copy the code from the document and paste it in the file create.py. This code creates a VM using Python libraries. Save the file by pressing Ctrl S. Now click on Open Terminal. Now run the command to execute the code Python 3 create.py my project SDK bucket SDK01. You should provide the project ID. The instance is created successfully. Now let's verify the VM instance is created successfully. Click on Navigation menu, navigate to Compute Engine and select VM instance. You can see the instance is created successfully. Now close the GCP Cloud Shell and log out from Google Cloud Platform account. This concludes your practice 3-3. Following this, you will have the quiz on this lesson. You can skip the quiz, however, I would suggest to take the test for self-analysis. You are in Lesson 4, Using Python in Data Science. In this lesson, you will be learning about the overview of data science libraries, processing data from CSV, XLS, and JSON file, what are data operation, cleansing and aggregation, chart properties and styling, statistical analysis of data using Python. Let's see the introduction to data science. Data science is the process of deriving knowledge and insights from a huge and diverse set of data through organizing, processing, and analyzing the data. The components of data science are statistics, virtualization, machine learning, and deep learning. The benefits of data science are it optimizes the customer experience, delivering relevant products, personalization of services, optimizing and improving operational data management. Let's understand the life cycle of data science. The main phases of data science life cycle are discovery, data preparation, model planning, model building, operationalize, and communicate results. Let's have a look on data science libraries. The data science libraries used in Python programming are SciPy, Matplotlib, NumPy, Scikit. Let's see what is NumPy. NumPy is numeric Python, which is a Python package for the computation and processing of the multidimensional and single-dimensional array elements. NumPy provides a convenient and efficient way to handle the vast amount of data. It is also very convenient with matrix multiplication and data reshaping. Advantages of NumPy are NumPy performs array-oriented computing. It efficiently implements the multidimensional arrays. It performs scientific computations. It is capable of performing Fourier transform and reshaping the data stored in multidimensional arrays. NumPy provides the inbuilt functions for linear algebra and random number generation. How do you install NumPy? NumPy doesn't come bundled with Python. It has to be installed using Python pip installer. The command to install NumPy is pip install NumPy. These are some of the data types of NumPy. Let's understand about NumPy functions. NumPy consists a large number of various mathematical operations and functions. Some of the functions provided by NumPy are trigonometric functions, hyperbolic functions, functions for rounding, arithmetic functions, exponents and logarithms functions, complex number functions. Let's have a look on what is SciPy. SciPy is an open source scientific library of Python which is used in mathematics, scientific computing, engineering, and technical computing. It is built on top of the NumPy extension, which means if we import the SciPy, there is no need to import NumPy. The SciPy library can be installed using pip or using Anaconda. The command to install SciPy using pip is pip install SciPy, and the command to install SciPy using Anaconda is conda install -c anaconda SciPy. The features of SciPy are as a collection of algorithms and functions built on the NumPy extension of Python. It provides high-level commands for data manipulation and visualization. It uses multidimensional image processing with a scipy.nd image submodule. It includes built-in functions for solving differential equations. These are some of the SciPy subpackages. Let's have a look on SciPy cluster. Clustering is a method of dividing the data sets into groups consisting of similar data points. Let's see the example of cluster. The k-means algorithm is used as an example for the cluster. It is a simple unsupervised algorithm. You can see the implementation of k-means algorithm in SciPy. This slide will brief you about what is Matplotlib. Matplotlib is a Python two-dimensional plotting library for data visualization and creating interactive graphics or plots. Using Matplotlib, the data visualization of large and complex data is easy. Applications of Matplotlib are correlation analysis of variables, visualize 95% confidence intervals of the models. The installation of matplotlib is dependent on Python distribution that is installed on your machine. If you are using pip, then the command to install matplotlib is pip install matplotlib. If you are using Anaconda, then run the command conda install matplotlib using Anaconda. Matplotlib architecture. There are different layers in the architecture of Matplotlib. They are backend layer. This layer is the bottom layer of the figure, which consists of the implementation of the various functions that are necessary for plotting. There are three essential classes from the backend layer. They are figure canvas, renderer, and event. Artist layer. This is the second layer in the architecture. It is responsible for the various plotting functions such as axis, coordinates on how to use the renderer on the figure canvas. The topmost layer is scripting layer, on which most of the code runs. The methods in the scripting layer almost automatically take care of the other layers, and all we need to care about is the current state. These are some of the functions of matplotlib. They are plot x-axis value, y-axis values, title string, figure, subtitle string, legend LOC, xlim, ylim, axis, set x label, set y label. Let's have a look on what is scikit. Scikit-learn is used to build models, and it is not recommended to use it for reading, manipulating, and summarizing data, as there are better frameworks available for the purpose. It is open source and released under BSD license. The command to install scikit-learn using pip is pip install scikit-learn. After installation, scikit-learn is used in Python code by importing it. Processing data from CSV XLS JSON file. Let's see how to process data from CSV file. Python CSV data is a comma separated value file which uses commas to separate values. Python data file format is useful in exchanging data and in moving tabular data between programs. The extension for a CSV file is .csv. To read the data from CSV in Python, import the required packages such as import pandas as PD. To load the file name .csv file into the data frame df, run the command df is equal to pd.readcsv by providing path of the file and file name .csv. Let's see the process of data from XLS file. The extension for an Excel spreadsheet is .xlsx or .xls. In XLSX, data is organized under the cells and columns in a sheet. To read the data from XLS in Python, import the required package such as import pandas as PD and load the file into the data frame. Let's see the process of data from JSON file. The acronym for JSON is JavaScript Object Notation. It is an open standard file format. It holds attribute value pairs and array data types. To read the data from JSON in Python, import the required package such as import pandas as PD and load the JSON file into the data frame. This slide gives the explanation on data operation in Python using NumPy. The data operation in Python using NumPy is n-dimensional array object, that is ND array. It describes the collection of items of the same type. Items in the collection can be accessed using a zero-based index. You can also have a look on the example of data operations in Python using NumPy. Data operations in Python using pandas. Pandas deal with the following two data structures. They are series and data frame. You can see the example of data operations in Python using pandas. Let's understand what is data cleansing in Python. Data cleansing is the process of fixing or removing incorrect, corrupted, incorrectly formatted, duplicate, or incomplete data within a dataset. Let's see the steps to clean the data. The first step is removing duplicate or irrelevant observations, then fix structural errors, filter unwanted outliers, handle missing data, and validate and QA. Aggregation in Python. Python has several methods that are available to perform aggregation on data. It is done using the pandas and NumPy libraries. The data must be available or converted to a data frame to apply the aggregation function. You can see the example of aggregation in Python. These are the chart properties and styling in Python. Let's see the chart properties. Labeling the axis, formatting line type and color, saving the chart file, histograms, logs graph, bar chart and pie chart. Let's have a look on chart styling methods. They are adding annotations, adding legends, chart presentation style. Let's understand the statistical analysis of data using Python. The statistical analysis is one of the possible analysis that can be conducted to verify that the data fits a specific distribution. The main two purposes of statistical analysis are describe, investigate. The statistical analysis can be divided into four parts. Choosing the model that better fits the data, parameter estimation of the model, calculate the similarity between the chosen model and the theoretical model. Apply a set of statistical tests to access the goodness of fit. In this lesson, you have learned about the introduction to data science libraries, processing data from CSV, XLS, and JSON file, what are data operation, cleansing and aggregation, chart properties and styling methods, statistical analysis of data using Python. The practices for this lesson are installing and configuring Anaconda and Jupyter Notebook, processing CSV, XLS and JSON data, creating visualizations by using chart properties and chart styling method, implementing Python application using chi-square. Practice for 4-1. Installing and configuring Anaconda and Jupyter Notebook. In this practice, you will learn to install Anaconda and launch Jupyter Notebook and set path for Anaconda in your local machine. You can copy the URL from the document to download the Anaconda. Scroll down to get the Anaconda installers. Choose 64-bit graphical installer. Once the installer is successfully downloaded on your local machine, double-click on the executable file. Click on Run. As the installer runs, click Next to install Anaconda. Read the licensing terms to install Anaconda in your local machine and click I agree. Select Just Me Recommended and click Next. Select the destination folder to install Anaconda, that is Users User Anaconda 3 and click Next. Select Register Anaconda 3 as my default Python 3.8 and click Install. On successful installation, verify that the installation process is completed. Click on Next. Now let's set up Anaconda. So click Next. Click Finish to complete Anaconda setup. Press Windows and run. Type System Properties Advanced.exe in the Run dialog box. In the Windows System pop-up, click on Environment Variables. Select the path under User Variables and click Edit. Click on New to add the path. Copy the path where the Anaconda is installed and add the path here. Click OK. Now click OK to close the environment variables. Now navigate to Start menu in your local desktop and search for Anaconda Navigator and click on this. It is now initializing Anaconda Navigator. Click on OK for Anaconda Navigator. You can see the Anaconda Navigator installed successfully. Now let's launch Jupyter Notebook by clicking on Launch. You can see the files in Jupyter Notebook. Now click New from the drop-down, select Python 3 to create a new Jupyter Notebook. Now let's save the file by clicking on Untitled in Jupyter. Provide the name for Jupyter Notebook as Hello World and click on Rename. Now in the Jupyter Notebook cell, write the code print Hello World and save the file by clicking this icon. Now let's run the code in Jupyter Notebook by clicking on Run button. You can see the output. Now click File from the menu and select Close and Halt. This closes the Jupyter Notebook. This concludes the practice 4-1. Practice for 4-2. Processing CSV, XLS and JSON data. In this practice, you will learn to process and read CSV, JSON and XLS file using Python. Before starting this practice, you can download the document for this practice from the resources. The document illustrates the step-by-step approach to this practice 4-2. In the first step, using an editor on your local machine, create a students.csv file under the specified directory. The file should be saved under D, Python, Python programs. In the students.csv file, add some data such as ID, name, and age. Save the file and close it. Open Jupyter Notebook. Let's create a new file by clicking on New, Python 3. Click on Untitled. Rename the notebook as Process CSV. Click on Rename. Copy the code from the document to read the students.csv file. Click on Save and run the code. You will find the data which was present in students.csv file. Now to display the particular column, copy the code from the document and paste here. Save the code and run. You can see the data with specified column such as name and age. Now let's try to read JSON file in Python. Using an editor on your local machine, copy the code which is present in the document and save the file as employees1.json. The file is successfully created. Now open your Jupyter Notebook and save the file as process.json. Click on New and select Python 3. Click on Untitled. Rename the notebook as process.json. Now copy the code in Jupyter Notebook, save the code and run the code. You can view the data present in JSON file. Now let's try processing XLS file. Using an editor on your local machine, create an XLS file. Provide the name of the XLS file as process XLS. Copy the data from the document. Save the file under the directory D, Python and Python programs. Now let's open new Jupyter Notebook. Rename the notebook as process XLS and click on rename. You can copy the code from the document, save the code and run it. You will get the output which is present in the XLS file. This concludes your practice 4-2. Practice for 4-3. Creating visualizations by using chart properties and chart styling. In this practice, you will learn to create charts and style the charts using Python libraries. Before starting this practice, you can download the document for this practice from the resources. The document illustrates the step-by-step approach to this practice 4-3. First, let's open Jupyter Notebook and save the file as charts. You can copy the code from the document. This code plots sine wave for 4 cycles. Let's save the code and run it. On successful execution, you can view the sine wave displayed below your code. Now let's create the bar graph in Jupyter Notebook. Copy the code from the document, paste in the notebook cell, save the file and run it. You can see the bar graph displayed below the code. Now let's create a pie chart in Jupyter Notebook. Copy the code from the document, paste it in the notebook cell, save the file and run the code. You can see the pie chart in Jupyter Notebook. This ends the practice 4-3. You can close the Jupyter Notebook. Practice for 4-4. Implementing Python application using chi-square. In this practice, you will learn to implement chi-square algorithm using Python. Before starting this practice, you can download the document for this practice from the resources. The document illustrates the step-by-step approach to this practice 4-4. Now let's open Jupyter Notebook and save the file as chi-square. Click on Python 3, click Untitled, rename the file as chi-square. Click on Rename. Copy the code from the document and paste in Jupyter Notebook cell. This code is used to distribute data using chi-square. Save the code and click on Run. On successful execution, you can view the data distribution graph displayed below the code cell. You can close the Jupyter Notebook. This concludes your practice 4-4. Following this, you will have the quiz on this lesson. You can skip the quiz, however, I would suggest to take the test for self-analysis. You are in Lesson 5, Python for Machine Learning. In this lesson, you will be learning about machine learning and types of machine learning, basic steps used for implementing ML, pre-processing techniques, algorithm for classifications, regression and the algorithms, exploring and clustering and SVM, algorithms for k-nearest neighbors, k-means, decision tree, recommendation system. Let's see the introduction to machine learning. Machine learning gives the capability to learn without being explicitly programmed to the computing systems. Machine learning uses various algorithms to build mathematical models and make predictions using historical data or information. Machine learning is classified into three types. Supervised learning. It is a type of machine learning method in which we provide sample labeled data to the machine learning system in order to train it, and on that basis it predicts the output. Unsupervised learning. It is a learning method in which a machine learns without any supervision. Reinforcement learning. It is a feedback-based learning method in which a learning agent gets a reward for each right actions and gets a penalty for each wrong action. Let's understand the basic steps used for implementing ML. Step 1 is gathering data, then preparing the data, choosing a model, training, evaluation, hyperparameter tuning, and prediction. Let's see what is data pre-processing. The data pre-processing is a process of preparing the raw data and making it suitable for a machine learning model. Data pre-processing also increases the accuracy and efficiency of a machine learning model. Data pre-processing is the first step of creating the machine learning model. The steps involved in data pre-processing are getting the data set, importing libraries, importing datasets, finding missing data, encoding categorical data, splitting dataset into training and test set. The last step is feature scaling. Let's have a look on the pre-processing techniques. Mean removal. It helps in removing any bias from the features. Rescale data. The values of every feature in a data point can vary between random values, so it is important to scale them so that this match specified rules. Standardization. With standardizing, the attributes with standard deviations transform them into a standard distribution. Normalizing data. The normalization involves adjusting the values in the feature vector so as to measure them on a common scale. Binarize the data. Binarization is used to convert a numerical feature vector into a Boolean vector. Encoding. It may be required to deal with numerical values that are few and scattered, and no need to store these values. In such situation, one-hot encoding technique is used. Label encoding. Label encoding converts word labels into numbers to let algorithms work on them. Let's see the algorithms for classifications. They are logistic regression, naive Bayes algorithm, stochastic gradient descent, k-nearest neighbors, decision tree, random forest, support vector machine. Let's look into what is regression in ML. Regression is an important and broadly used statistical and machine learning tool. The key objective of regression-based tasks is to predict output labels or responses which are continuous numeric values for the given input data. The types of regression models are simple regression model. This is the basic regression model in which predictions are formed from a single feature of the data. Multiple regression model. In this regression model, the predictions are formed from multiple features of the data. Exploring on clustering and SVM. Clustering is a set of techniques used to partition the data into groups or clusters. SVM. Support vector machines provide an efficient mechanism to construct a separating hyperplane surrounded by the thickest margin using a set of training data. To implement SVM in Python, import the standard libraries such as importing NumPy as NP, import matplotlib.pyplot as PLT, from SciPy, import stats, and so on. Let's try to understand the k-nearest neighbors algorithm in Python. The k-nearest neighbor algorithm is used to solve the classification model problems. K-nearest neighbors or KNN algorithm basically creates an imaginary boundary to classify the data. This is the example program to illustrate how KNN algorithm works. Initially, we import the libraries, then load the data, create feature and target arrays, split into training and test set, then predict the data set. This slide will brief about k-means algorithm in Python. K-means clustering is a clustering algorithm that aims to partition an observation into k number of clusters. The steps to do k-means algorithm are initialization, assignment, and update. This example illustrates the k-means algorithm. Let's have a look on what is decision tree. The decision tree algorithm belongs to supervised learning algorithms. This algorithm can be used for solving regression and classification problems. The types of decision tree are categorical variable decision tree, continuous variable decision tree. Let's understand what is recommendation system. The recommender system are machine learning based systems that scan through all possible options and provides a prediction or recommendation. The recommender system performs well even if new items are added to the library. A recommender system's algorithm expects to include all site properties of its library's item. There are two types of recommendation system: content filtering recommender system, collaborative filter based recommender system. In this lesson, you have learned about machine learning and types of machine learning, basic steps used to implement machine learning, pre-processing techniques, algorithm for classifications, regression and algorithm, exploring on clustering and SVM, algorithms for k-nearest neighbors, k-means decision tree, recommendation system. The practices for this lesson are: implement clustering by categorizing items to group, implement ML application using linear application, classify the handwritten digits using Python, create a decision tree. Practice for 5-1. Implement color quantization using k-means algorithm. In this practice, you will learn to implement the color quantization using k-means by reducing the number of colors required to show an image. Before starting this practice, you can download the document for this practice from the resources. The document illustrates the step-by-step approach to this practice 5-1. Open the Jupyter Notebook, save the file as k-means. Click on New, click Python 3, click on Untitled, k-means, and click Rename. You can copy the code from the document and paste it in code cell. Save the code and run the code. On successful execution, you can view the image displayed below your code. Now, to resize the image to 2D array, copy the code from the document and paste it in the notebook code cell. Save the code and run the code. You can see the output as fitting the model is done in 2.772 seconds. Now let's predict the color indices. Copy the code from the document and paste it in notebook code cell. Save the code and run it. It is predicting the indices. This process is done in 0.379 seconds. Now let's create a user-defined function to recreate the image. Copy the code from the document, paste it in notebook code cell. Save the code and run it. On the successful execution, view the quantized image displayed below the code cell. You can close the Jupyter notebook. This concludes your practice 5-1. Practice for 5-2. Implement ML application using linear regression. In this practice, you will learn to build and train a model linear regression algorithm. Before starting this practice, you can download the document for this practice from the resources. The document illustrates the step-by-step approach to this practice 5-2. Open the Jupyter notebook and save the file as linear regression and click on rename. Copy the code from the document to load the dataset. Save the code and run it. Loaded the dataset successfully. Now let's split the data into training and test pair. Copy the code from the document. Save the code and run it. The output says splitting dataset into training and test pair. Let's create an object to train the dataset. Copy the code to create an object and train the model using training set. Save the code and run it. You can view the output displayed below the code cell. Now copy the code from the document to predict the model. Save the file and run it. Again, copy the code from the document to plot the graph using test pairs. Save the code and click on Run. On the successful execution, you can view the graph displayed below the code cell. Make sure the line fits the dataset. You can close the Jupyter notebook. This concludes your practice 5-2. Practice for 5-3. Classify the value of handwritten digits using Python. In this practice, you will learn to train the model to classify handwritten single-digit number using classification algorithm. Before starting this practice, you can download the document for this practice from the resources. The document illustrates the step-by-step approach to this practice 5-3. Open the Jupyter notebook and let's save the file. Click on Untitled, Classify Digit and rename. Copy the code from the document to import the libraries and load the digit datasets. Save the code and run. On successful execution, you can see the output displayed as loaded dataset. Now copy the code from the document to build, train and plot the predicted digits. Save the code and run the code. On the successful execution, you can view the training and predicted images. You can close the Jupyter notebook. This concludes your practice 5-3. Practice for 5-4. Create a decision surface and decision tree. In this practice, you will learn to create a decision surface and decision tree using iris dataset with respect to sepal and petal size. Before starting this practice, you can download the document for the practice from the resources. The document illustrates the step-by-step approach to this practice 5-4. Open your Jupyter notebook and let's create a file. Click on New, Python 3. Click Untitled. Provide the name as Decision Tree and click Rename. Let's import the necessary libraries. Copy the code from the document and load the iris flower dataset. For that, copy the code from the document. Save the code and click on Run. Now let's plot the decision surface by copying the code from the document. Save the code and run it. On successful execution, you can see the decision surface displayed below the code cell. This is the decision surface of a decision tree using paid features. Now let's plot the decision tree classifier. Copy the code from the document and paste it in Jupyter Notebook code cell. Save the code and run it. After the successful execution, you can see the decision tree displayed below your code cell. You can close the Jupyter Notebook. This concludes your practice 5-4. Following this, you will have the quiz on this lesson. You can skip the quiz, however, I would suggest to take the test for the self-analysis.